Good morning. We are talking about sunlight throughout the year. We've been talking about the seasons for the last few days, and we're going to do investigation 3B. And if you will make sure that you have a highlighter so that you can follow along, I do want you to highlight what I highlight. I'm going to be better about checking that when you turn it in. And you'll notice that in this screencast, I am not going to show you on the screencast the answers that I have selected. I'll talk about them, but you'll have to select them yourself because I want to make sure that you're listening to the screencast and not just cruising through it trying to see where I've selected answers. So anyway, just that's a word of warning. But let's talk about sunlight throughout the year. First of all, we're going to go through the objectives. There's a couple of things I want to point out. That's worthy of some highlighting. It says all weather and climate begins with the sun. That is because solar radiation is the only significant source of energy that determines conditions at and above the Earth's surface. So please take your highlighter, highlight that sentence. And then it goes on to say the average rate at which solar radiation is received outside Earth's atmosphere on a surface oriented perpendicular to the sun's rays is about 2 calories per square centimeter per minute. Okay? Or 1,370 watts per square meter. Okay? The amount of solar radiation that actually reaches Earth's surface at any particular location is quite different and changes continually during the daylight hours. Think about cloud cover and other conditions that would vary the amount of solar radiation. Also, where you are on the Earth, what angle the sun is coming in at, etc. Okay, because remember, they were talking about a surface oriented perpendicular to the sun's rays, but we know that not all areas of the Earth receive sun from directly overhead. So that's going to affect the amount of energy received at each particular spot. Okay? All right. The nearly spherical Earth, rotating once a day on an axis inclined to the plane of its orbit, presents a constantly changing face to the sun. Wherever there is daylight, the daily path of the sun through the local sky changes through the course of a year. Everywhere on Earth, except at the equator, there is variation in the daily number of hours of daylight throughout the year. In addition, the atmosphere absorbs and scatters the solar radiation passing through it. Clouds especially can block much of the incoming radiation. Okay? So go back. Make sure you highlight that everywhere on Earth except at the equator, there is variation in the daily number of hours of daylight throughout the year. Okay? And highlight this. Clouds especially can block much of the incoming radiation. So, for instance, at the equator, you're going to get about 12 hours of daylight and about 12 hours of darkness throughout the year. But on a daily basis, it's possible that clouds can be your big factor as to how much solar radiation you're getting. Okay? So the purpose of this investigation is to consider the variability of sunlight received at different latitudes over the period of a year. Okay? All right, moving down, let's look at the introduction. It says, examine the accompanying graph of figure 1. All right, hang on just a second. Let me find my color one. Okay, here is figure 1. Okay. And if you'll read and follow along with me, even though I've got the graph up here, I'm still on page 1. It says, examine the accompanying graph of figure 1. Data points plotted on the graph represent measurements of actual solar radiation received daily on a horizontal plane at Earth's surface, averaged over each month, at near equatorial, which would be the Singapore location. So Singapore is near the equator. At mid-latitude, which would be Brockport, New York, we'll probably think that's close to 45 degrees, which actually it says over here on the key. Singapore is at a latitude of 1.5 degrees north. Brockport, New York is at 43.5 degrees north. And the polar locations, which is going to be the South Pole in Antarctica. Okay, so you've got 3 different locations and 3 different latitudes. On figure 1, month of the year is plotted along the horizontal axis, and average daily incident radiant energy in calories per square centimeter per day is plotted vertically. So let's take a look at what they're talking about. Let me get this where you can see the X and Y axis. So down here, here's December, D, January, February, March, April, May, June, July, August, September, October, November, December, again, showing that eventually the months repeat. Okay. On the horizontal axis, so I'm reading the introduction again. It says, on the horizontal axis, the longer marks represent the first day of each month and the shorter marks represent mid-month. Okay, so D is actually, that's mid-December, because there's the long mark, and that long mark ends December and begins January. So the J is in the middle of January, and the F is in the middle of February. The M marks the middle of March, the A marks the middle of April, etc. Okay? All right, so I'm going to remove this, and let's go back to our introduction. Okay, so we need to remember that on the horizontal axis, the longer marks represent the first day of each month and the shorter marks represent mid-month. So just keep that in mind. And it says, construct an annual solar radiation curve for each of the 3 locations. Do this by drawing a smooth curved line connecting the radiation values already plotted for each location. So let's do that real quickly. Okay. So you're going to need to flip to your graph. And I'm sorry yours is in black and white, but you do have little squares representing Brockport, little circles representing Singapore, little triangles representing Antarctica. So even though it is in black and white, you can still tell which points are for what location. Okay. All right. So we're going to draw a smooth curve connecting our values. I'm going to use red for Singapore because on the color one, the dots for Singapore are red. Okay. So I'm going to connect those. And remember, December repeats, so we've got December plotted twice so that we can kind of have a continuous graph. Okay, so there is Singapore in red. I'm going to do Brockport in green. Okay, Brockport's the little squares. Okay, so that's Brockport in green, and we're going to do Antarctica will be in blue. Those are the blue triangles. Okay. Ooh, what do you notice down here about Antarctica? What's the average daily radiation for a lot of the year? It is basically 0. Because you think about it, we know at the polar locations, they are in darkness for part of the year. So obviously, during the southern hemisphere's winter, we're going to get no radiation received because the sun's not above the horizon for that location. Okay? All right. And I'm going to go back over here and make sure I mark that Antarctica is in blue. Okay? Okay, so join me in just a second for screencast number 2, and we'll continue with this exercise.